Okay, let's jump right in. Welcome to The Explainer. Today we're taking a fascinating journey that literally starts deep beneath our feet and ends, well, right inside our own minds. We're going to trace the massive planetary geological forces that shape our world, and then we'll connect them directly to the behavioral psychology of how we actually survive them when they strike. We're looking at the science of earthquakes and tsunamis and, honestly, unpacking why human beings sometimes make the absolute worst decisions during a crisis.
Here's our roadmap for this explainer. We'll start with the Earth's shifting plates, then look at the birth of a tsunami. After that, we'll bring it down to the human level. Survival fact versus myth, the psychology of misinformation, and finally, the absolute safest action you can take. All right, let's get into it. Section 1. The Earth's shifting plates. The planetary engine.
So, when we look at the Earth's topography, we are really looking at a giant planetary scale puzzle. Our planet's outer shell isn't one solid piece. It's broken up into these massive tectonic plates, and they are constantly shifting, grinding, and moving all over the globe. Now, this moving crust creates what geologists call divergent borders. These are active zones where huge land masses are literally pulling apart from one another. It's just this continuous, dynamic process of tearing and rebuilding, and, it's been happening for billions of years. And you can see how these active tectonic zones kind of snake their way across the entire planet. But notice something wild here. The vast majority of these boundary lines are completely hidden from our view. They're situated deep, deep underwater along the ocean floor. Because of that, we really have to recognize that the immense pressure and tectonic movement happening down there is the true geological source of both planetary creation, literally making brand new crust, and, unfortunately, profound human catastrophe. But divergent borders don't just pop up overnight. They evolve in 3 distinct steps. First up, we have rifting. This is where the terrain elevates due to thermal expansion, and a massive rift valley opens up. Second is the juvenile phase, which is when the actual process of creating new oceanic crust really kicks in. And finally, we hit the mature phase. That's characterized by the formation of thick deposits and serious morphological reshaping. So it's really this cycle of constant, slow-motion creation. But what happens when plates slide past each other horizontally instead of pulling apart? Well, that creates transform faults, kind of like the famous San Andreas fault. Think of it this way. Imagine 2 people standing on opposite sides of a fault line. If they're on different blocks of land, they're going to move relative to one another. But if they're on the same block, just on opposite sides of the fault's edge, they actually end up moving in the exact same direction. It's a horizontal displacement. And when these plates finally slip, bam, that triggers massive seismic events. Moving on to Section 2, Birth of a Tsunami, Oceanic Seismic Events. So, the crucial thing here is defining what we're actually dealing with. A tsunami, which translates from Japanese as harbor wave, is not just an unusually big wave. Your normal ocean waves, those are created by wind. A tsunami, on the other hand, is a massive, sudden displacement of a gigantic volume of water generated by profound seismic activity. The energy doesn't just skim the surface, it literally moves through the entire water column. Now, while massive earthquakes are for sure the main culprits displacing all this water, they aren't the only triggers. Submarine landslides and underwater volcanoes can also shift huge amounts of water. In fact, these events often happen right alongside a major earthquake. They kind of stack together, amplifying the tsunami's terrifying speed and destructive power as it races toward the coast. Section 3. Survival. Fact versus myth. Choosing the action. I want you to think about this for a second. When the Earth suddenly starts shaking violently, who do you trust? In those frantic split seconds, the information you choose to rely on is literally the difference between life and death. And there's this incredible contrast in what people choose to believe in that exact moment. On one side, we've got the scientifically backed, government-recommended standard drop, cover, and hold on, basically getting under a sturdy piece of furniture. On the other side, we have the triangle of life. This is a highly circulated, internet-fueled myth that tells you to hide in a void next to a piece of furniture rather than under it. Listen, the triangle of life is incredibly dangerous. Why? Because it exposes you directly to falling objects, which are the real hazard in an earthquake. Yet people still believe it. So why is that? Well, that brings us to Section 4, the psychology of misinformation, believing myths. To really unpack this, researchers from Jacksonville State University and a few other institutions conducted a fascinating empirical study.
They surveyed 647 residents in Mianyang City, China. Now, this is a region that was heavily struck by the devastating 2008 Wenchuan earthquake. The researchers wanted to know exactly what factors influence people's decisions to choose one protective action over another.
And what the data reveals is this brilliant yet totally alarming disconnect in human behavior. When asked directly, the respondents claim to highly value quality attributes in an information source. Things like the source's responsibility, their trustworthiness, their actual seismic expertise. But when the researchers analyzed which action people actually intended to take, a completely different story emerged. People's intentions to adopt the dangerous triangle of life myth were heavily influenced by quantity attributes, meaning how easily accessible the information was and how many times they saw it repeated across different media.
The danger here is summed up perfectly by a psychological phenomenon known as the availability heuristic. Basically, if a protective action is easy to understand, mentioned often by multiple sources, and easy to access, people will adopt it, even if it's dead wrong. This fast food style of information consumption actually trumps real scientific expertise in the minds of many, leading them to adopt a posture that puts their lives at way greater risk. Which leads us to Section 5, the only safe action, based on global experts.
So, the absolutely crucial point to remember is this. Earthquakes themselves do not kill people. Collapsing infrastructure, flying glass, and falling debris kill people. Dropping to the ground, taking cover under a sturdy desk or table, and holding on tightly is universally the most effective survival strategy, period. It provides a physical shield against the most likely cause of injury during a tremor. It is literally the only immediate protective action globally backed by actual disaster experts.
I want to leave you all with a bit of a provocative thought. As we've seen today, the tectonic forces beneath our feet are incredibly powerful. But honestly, perhaps equally powerful is the tide of misinformation swirling on our screens. In a digital age where dangerous myths are just a click away, how will you verify life and death information before the ground actually starts moving? Evaluating our media consumption habits today could very well be the thing that saves our lives tomorrow. Thanks for joining me on this explainer, and remember, keep asking the right questions.